Hello and welcome to this lab demonstration on using a vSAN data store. After completing this lab video, you will be able to view a vSAN data store configuration and identify the virtual machine components on the vSAN data store. vSAN provides storage that is object-based and policy-driven, and it is a highly scalable storage solution. While it is not that difficult to set up a simple vSAN data store, it can get very complex in more advanced solutions. VMware offers dedicated courses on vSAN, so there are lots of things to know if you want to design, configure, manage, or troubleshoot vSAN's data stores. In this lab here, we will just have a look at the most important components of a basic pre-configured vSAN data store. So consider this lab as an introduction to vSAN storage, but make sure that you dig deeper into the subject before you touch the vSAN configuration in a production environment. To benefit from this lab video, you should be familiar with the vSphere client user interface, and you should have a basic understanding of storage solutions. In the first task of this lab exercise, we will view information about the ESXi cluster that has vSAN enabled. We will examine the vSAN disk groups, we will have a look at the VM kernel adapters that are used for the vSAN network, and we will check the capacity of the vSAN data store. In the next task, we will view the vSAN default storage policy and how it affects the available space on the vSAN data store. Finally, in the last task of the lab, we will power up a virtual machine on the vSAN data store and examine the objects of the virtual machine that are stored on the vSAN data store. I'm sure I provided you enough good reasons to watch the following video on using a vSAN data store. Now, let's get started. We want to view the vSAN configuration on vCenter server SA-VCS01. So the first step is to connect to this server. Then we log in as administrator at vsphere.local. In the first task of this lab exercise, we will view the existing vSAN data store configuration of the SA Compute 01 cluster that is part of the SA data center. We will look at the ESXi hosts, the disk groups, the VM kernel port that is used for the vSAN storage, and the vSAN data store. So first thing we will do is to verify that vSAN is actually enabled on our cluster. To do that, I go to Menu, Hosts and Clusters. We want to look at the SA data center, so let's expand this one. Let me expand the cluster and then select the cluster SA Compute 01. Now in the right pane, we click Configure. And under Configuration Quick Start, we can see here that the selected services do include vSAN. Actually, it's the only service, but yes, vSAN is enabled on this cluster. And we have a green check mark, so vSAN is operating on this cluster. Now let's have a look which ESXi hosts belong to this cluster. So we click on Summary. And now when we scroll down, under cluster resources, we can see that 3 hosts are in this cluster. Now, if we click Hosts, then in the Hosts tab, we can see the list of these ESXi hosts. These are SA ESXi 04, 05, and 06. Now let's go back to the Configure tab. And under vSAN, I have to scroll down a little bit. Disk Management. We can see our ESXi hosts and the configured disk groups. Let me resize this pane a little bit so that we see all 3 hosts and their disk groups. So you see that we have host ESXi 06, 05, 04, and each one has a disk group. And the number of disks is 3, actually for all of them. The type of the disks are all flash. And when you select the disk group up here, then in the lower part, in the lower pane, you can see the members of the disk group. And when we look at the disk group here of server SA ESXi 06, we can see that there is one disk with a capacity of 5 GB, and the disk tier is cache, whereas the other one have 10 GB each, and their disk tier type is capacity. So in this case, our disk group is an all-flash disk group. You could also have so-called hybrid mode. In hybrid mode, you would have a cache tier, which also has to be a solid-state disk, but you could have spinning disks for the capacity tiers. That makes hybrid mode then. Our disk group here has 3 disks, and actually this is the same on every server. Each server has 3 disks, and the sizes are also the same on every server. It's always a 5 GB cache tier and 2 disks, 10 GB each, as capacity tiers. So we are using 3 disks per disk group. Actually, the maximum would be to have 1 cache tier and 7 capacity tiers. The maximum number of disk groups per ESXi host is 5. So you would then have 5 flash disks used as cache tiers, and you could have up to 35 capacity disks. We have a small cluster here, but if you think of the biggest possible cluster with 64 hosts, then you can create a huge vSAN storage. Now let's have a look at the network configuration related to the vSAN data store. Actually, we want to have a look at the VM kernel port. vSAN uses a VM kernel port. So for that, we have to select one of our ESXi hosts. Let's click SA ESXi 04. Then we click the Configure tab. And under Networking, we select VM kernel adapters. And actually VMK2 is our VM kernel adapter that we use for vSAN. When you look below, under Port Properties, we see the network label, so the name of the port group, and the enabled services lists vSAN here. So this shows us that this port group is used for vSAN. Now let's have a look at the storage capacity of our vSAN cluster. In the navigation pane, we select the cluster SA Compute 01. Then in the right pane, we click on Summary. And in the Summary tab, when we scroll down, then we've got the vSAN overview in the bottom right of the screen. And you see there is a link here, Details. If we click that one, we are taken to the Monitor tab, and we see the Capacity Overview pane on top. So it shows us that 434 GB are currently in use out of a total of almost 60 GB. So the free space is a bit more than 55.6 GB. Depending on the storage policy that you apply, you may have less space that you can actually use for virtual machines. That's what we want to look at in the next task. So in this second task, we want to look at the vSAN default storage policy and how we can use the capacity analysis tool to find out what the remaining usable space of the vSAN data store is, based on a certain storage policy. We will also have a closer look at the currently used space. What is saved on the data store, how is it stored, and how much space is used for what. To look at the storage policies, we have to go to the menu drop-down and we select Policies and Profiles. Then we click VM Storage Policies. And in the right pane, we want to have a look at the existing vSAN default storage policy. So we select this one. And in the rules pane, we can see down here that failures to tolerate says one failure, RAID 1 mirroring. So that's the option that is chosen on this policy. We want to be able to survive the failure of one ESXi host, and the way to do that should be by using RAID 1, so mirroring of the data. Now we want to have a look at our storage and how the storage policy affects the actually available space. So we go to storage. Now in the navigator pane under storage, we go to our data center, SA data center, and here we have our vSAN data store. We select this data store, and now on the right, in the monitor tab, under vSAN, there is the capacity item. We have already seen this page earlier at the end of the previous task. So let's have a look at the space again. 434 GB are in use. The total capacity is almost 60 GB. Now, since the actually used storage depends on your storage policy, for example, when we use RAID 1, we consume twice the space that our VM actually has. The storage policy is very important when you want to estimate how much space do you have left that you can use by virtual machines. And down here in the second pane, we have the usable capacity analysis. So this is a tool that helps you analyze how you can use the available space on the disks, which is more than 55 GB, and what that space means based on a certain policy. So you have a drop-down list here. All the policies that you see here exist by default. We didn't create our own storage policy, but you could select a policy now. If you created different policies, then you could select the policy that you created or one of them. And now you get an analysis of what is the effective free space with the chosen policy. So if we keep the vSAN default storage policy, which remember has a fault tolerance of 1 provided by RAID 1, then the effective free space is half of the size that we have available on the disks. So the disks have a free space of 55.61 GB, and the effective free space with this default policy that uses RAID 1 is half of it. So 27.81 GB. Remember, we have 3 ESXi hosts here. They all have the same disk group configuration, which was 3 disks, a 5 GB cache tier, and 2 capacity tiers of 20 GB each. Of 10 GB each. That gave us 20 GB of usable space per ESXi host. We had 3 hosts, so the total is 60 GB, and that's what we see on this storage. You have to ignore the cache tier, the 5 GB disk, because as the name says, that's only for caching. So on our vSAN data store, 4.34 GB out of 59.95 GB are in use, as we can see up there in the capacity overview. The space left, as we can see on the right hand side, is 55.61 GB. If you want to know in more detail how we consume the 4.34 GB, then you can look at the bottom pane of this screen. It shows the used space by categories. Let me start at the bottom and expand the system usage item. You see that the system consumes 2.54 GB. And when I scroll down a little bit, you can see how much space it uses for what component. We've got performance management objects, file system overhead, and checksum overhead. Now let's expand the VM category. Down at the bottom of this category, we see the VM home objects, and they consume 740 megabyte. These objects store information that you usually find in non-hard disk virtual machine files, such as VMX, log, NVRAM, and VMSD files. As said, in this case, these objects consume 740 megabyte. And above, we see the VMDK object, and it shows the size of the primary data and then about the same size for the replica. So this is the RAID 1 copy of the virtual machine disk file that we know as VMDK files. So the VM itself consumes a bit more than half a gigabyte, but since we store it twice based on our RAID 1 storage policy, the VMDK object sums up to about 1 gigabyte. And in total, the VM home objects, 740 megabyte, and our VMDK files that consume a bit more than 1 gigabyte, this sums up to 1.8 gigabyte for the VM category. To wrap this up, our virtual machine that we store on the vSAN Datastore has about 500 gigabyte data on its disk. It consumes 1.8 gigabyte in total, as we can see up here. The system consumes 2.54 gigabyte, and that's how we end up with the total used space of 4.34 gigabyte that we were able to see at the top of this screen up here. Okay, I think you have a much better idea now about the storage policies and how you can verify how much space is consumed, by what components it is consumed, and what you can do with the remaining free storage, depending on the storage policy that you will apply to your virtual machines. Talking about virtual machines, in the next and final task of this lab, we want to have a closer look at the virtual machine objects that are stored on the vSAN Datastore and how these objects differ when the virtual machine is powered off or up and running. So what we do first is we want to have a look at the VMs that exist on this Datastore. So in here, in the vSAN Datastore, we click the VMs tab. And we see that there is a single virtual machine that resides on this Datastore, Photon 03. So let's click this VM. And that takes us to the VM view of Photon 03. Now we want to power on that virtual machine. And when we now click the Monitor tab, under vSAN, we can select Physical Disk Placement. And now we see the objects that are stored on the vSAN Datastore of this virtual machine, Photon 03. And we see three main categories. We have the hard disk itself, the VMDK, VM home category, and virtual machine swap objects. So the top one is the virtual machine disk file. That's what we usually find in VMDK files on other types of storage. VM home objects stores information that we usually find in VMX files, log files, NVRAM files, VMSD files, and similar. The virtual machine swap object, as the name says, stores the information that we usually find in the .vswp files. And for each object, we can see the role that each ESXi host plays, and it can be either type witness or component. A witness disk does not store VM data, but only metadata that helps the VM finding the right resource in a certain error situation. So you will see that we have two components per object. This is because we have a RAID 1 storage policy. The data are stored twice, they are mirrored. So the components that we see here, they store the actual data. The witness disk, as said, just stores metadata. So again, to summarize, we see three types of objects: the hard disk, VM home objects, and the virtual machine swap object. This is while the machine is powered on. The virtual machine is currently running. So let's have a look how these objects change when the virtual machine is not running anymore, when we shut down the virtual machine. So we right-click the virtual machine in the navigator pane, we select Power and shut down Guest OS. We confirm by clicking Yes, and you will see that once the virtual machine is powered off, we will also see a difference in the objects that are stored. Why? Because the virtual machine swap object is only used while the machine is up and running. So let's refresh the page here, and you can see that the swap object category is gone. Only hard disk objects and VM home objects are left. Congratulations! You have completed the Using a vSAN Datastore lab demonstration video. In this lab, we first viewed the vSAN Datastore configuration in our cluster. We verified that vSAN is enabled in the cluster, had a look at the disk group configuration and at the VM kernel adapter, and we checked the vSAN capacity of our vSAN Datastore. Then, we viewed information about the vSAN default storage policy and analyzed the currently consumed space and the effective free space based on the default storage policy. Finally, we examined the virtual machine objects that are stored in the vSAN database when a virtual machine is running and what objects are deleted when we power off the virtual machine. This lab exercise gave you an introduction to vSAN Datastores. Remember that there is much more to discover related to vSAN storage, and be cautious when you deal with a production environment. Thank you for watching this lab demonstration video. I hope the knowledge acquired here will help you with your daily job assignments, and good luck as you continue your journey in VMware world.